Hello, welcome to another session of the Houdini training. My name is Gianvito Serra, and today we are going to be learning, seeing some examples of how we can actually use attributes to drive, control how geometry gets manipulated or created, okay? And we're gonna use the example that we were using before, where we were actually using, having a forest generator. Instead of actually driving now this with stamping, or rather we'll still be using stamping, but we're going to be using attributes as well to drive some of this effect. Okay, so to get started, just to recap a little bit, I'm going to go ahead and delete these expressions for now so that we don't have to see those. If you guys remember, we had a grid which we actually use a mountain to give a little bit of undulation. Then we had an L system which creates a tree which we had to rotate on the Z up to be able to actually copy it properly. And then we have and then we actually had a transformation for actually rotating the trees. Okay, so some of these things were controlled by stamping variables when we actually came into this. We also learned a little bit about how we can use paint to actually drive, the location of the points, as well as the normal sub to actually create normals, which we could use to actually orient the trees. So these operators created attributes which we're using to drive some of the operations. Okay, so the scatter node and the copy, which does the copy ultimately. Okay, we merged that with the terrain, and then we came back to this node. Cool. All right, so we're gonna do now that we know a little bit about attributes, a few things that we want to do is that we want to be able to actually use attributes to drive where the scale of the trees, as well as also whether we keep a tree or not, and which we're kind of doing here with the color, but we're going to do it a little bit different for the purposes of learning here, as well as using attributes, be able to manipulate attributes such as the normals to actually be able to determine the direction of the trees. Okay, so to get started, let's go ahead and actually clean a few things up. We're going to actually start from the mountain operation. Okay, and we're going to branch off on this side to actually create a few attributes that we're going to use on this tutorial. Okay, so the first thing that we want to do is that we want to create attributes that will allow us to control the different parts of our copy operation. Okay, so we are going to have to go ahead and do an attribute create. Okay, which allows us to create an attribute. Okay, and the first thing that we want to do, and I'll make this window a little bit bigger, is use the attribute create to create the actual attributes. The same way how you have seen me using the normal sub or the paint sub or the color sub to create colors and normals, attribute create allows me to create arbitrary attributes that go with my geometry. Okay, so they can be colors and normals, but they can also be really whatever arbitrary attribute I feel to create. Like in this case, what I want to do is that I want to create a scale attribute, which is going to drive my tree scale. And then I am going to create, and that's going to be a point type, of course. And it's going to be also a float, okay, because we want to be able to control like the actual tree height and stuff like that. Okay, we're gonna default, probably 1 is not a good default value for the scale, so we're gonna go with 1 as a default value. Okay, so if we look at my node network and I look at my attribute create and the middle mouse, you will notice that now for every point in the grid I have an attribute called scale. Okay, and if we right click on this and look at the spreadsheet, you will notice that for every point I have my position, and then I have this scale that I just created. Okay, now if I actually modify the default value here, or the value that I'm writing, you will notice that that changes on my geometry spreadsheet as well. An important lesson to learn about the geometry spreadsheet is that it is a viewer just like any other viewer inside of Houdini, so it will cause things to cook if you have a spreadsheet open somewhere. So be very mindful if you see things cooking a lot in Houdini on whether you have a spreadsheet open incidentally. Okay? So very cool. We have our scale here, which we just created. And now one thing that we can, and then we're going to go ahead and create a few more. So we want to also create a attribute to keep the trees. So we're going to add another one called keep, which is going to allow us to determine which trees we're going to keep and which trees we're not going to keep. Okay? And then we are going to give it a default value of 0, because on that one we want to start with 0. And then we're going to add one more, which is going to be an attribute for the actually two should be fine for now. We'll start with these two. Okay, so now if we look, now I just created one called keep in the middle mouse here. You will notice that I have keep and scale also as point attributes here. Okay, if we go to the spreadsheet, for every point now I have keep and now I have scale. The way how attribute create works is that every time that we press a plus here, we can continue to create attributes and set them to values. Okay, very cool. Okay, so now that I have my attributes, I need a means to be able to paint them. Okay, so to paint them, we can use a paint operator as well. The paint operator by default paints colors, and it creates a color attribute, as you see here. Okay, but we can tell the paint attribute not to actually use color, but to also to just operate on a different attribute altogether. Okay, so if we come to override color here and turn that on, we can say that, you know what, I don't want to paint the color, I want to paint the scale. Cool. One thing that you'll notice that happen is that the moment that I did that, the grid went red. And the reason why that happens is because, if you remember, in my attribute create, I set my default value for my scale to 1. Okay? The paint sub is still using colors to show what the attribute that I'm painting is. Okay? But the actual attribute that I'm actually painting is scale. Now scale is also a linear attribute. It only has one float value, not 3 like colors do. One thing that we can do, if you like to see, and I'll go lock this window so that we can see it, is that we can actually add more channels to, say, for example, I have 3 channels, and actually see that affect the color that we get there by default. Okay, and that's basically just because of the value that we're writing by default on our colors. Okay, keep in mind too that what we're looking at here is a high dynamic range frame buffer, so we can go beyond 1 on our colors to see that. Okay, for the purposes of this, let's go back to the scale being just a single linear value. Okay, now because it's a linear value, and I'll get the pin here out so that we can see the paint operation things, we can also switch the way how we visualize things, and I'll show that in a second. But first, what I like to do is that I like to fill the scale. I like to start actually painting a little bit of a scale. So let's go ahead and actually, we have a good radius. Okay, I'm going to set my color to something like, I don't know, something like around a gray or so, and I'm going to start painting here. Now you will notice that what I'm actually painting here does not look anymore like color, but it is actually like a heat map. Okay, this heat map is symbolizing, the actual values of the actual scale attribute that we're seeing here. If you open the spreadsheet, you will notice that the scale here, as I actually paint, is being modified. Okay, likewise, we can go back to a value of 1 and go back and paint this area, and you will see that the values on the spreadsheet are being modified as we do this operation. Okay, we can say that we want to actually smooth the operation and apply, and you will see that now we get like a nice soft transition that represents the actual value of the scale across my field. Okay, can even take the lighting off so you can see that a little bit more clear here. Okay, so the heat map represents the actual scale value. Can even go back to grayscale if you wanted to just look at it this way. Okay, but infrared sometimes a little nice helpful way of actually seeing how it all works. Okay, cool. So now that we created an attribute called scale and we have actually painted some values on it, let's go ahead and actually paint the keep attribute. Okay, I'm going to go back to shader mode here. So the next attribute we're going to paint is keep, and which is also a linear attribute. Just make sure here, yeah. And now the default value for that is 0, which is basically the blue that we see here. So if we actually come here and start actually growing my radius, we can start actually painting the areas where we want the trees to be. So we're going to use white for that, and we're going to say, well, we want trees over here, and I want trees over here. Okay, and I want trees over here. Okay, maybe a few here. Cool. If we go over here now, we will see on the spreadsheet that both the keep and the scale have actually been modified using the painting operations. Okay, very cool. Alright, so similar to how we did before, we can now add also a normal operator to create a normal attribute. Okay, which gives me this. I'm going to set it on the points because I want it to be a point attribute, not a vertex attribute. Having normals on the vertices is useful if you want to have hard edges, which in this case I really don't want. I'm okay with the way how the normals look here. Okay. Now for the normals, we can use a comb, as in combing your hair, operator, to come in and actually paint the normal direction, to be almost like brushing normals, if you will. Okay, so basically we can come here and we can start brushing the direction of the normals. It's pretty cool. The reason why we're getting a black mark here is not because we're actually painting black, but because we're simply modifying the actual normals of the mesh. Okay, so it's affecting the shading, as you can see. Okay, so to smooth, we need to come here and set this from comb to smooth. Make sure the operation for all is set to comb, and then we can come in here and actually smooth out the normals. Okay. Now, one thing I like to show as an alternative, and in this case I think I'll use this method, is that we can also use a smooth operator. Now, the smooth operator by default smooths the actual point positions, which you can see is what it's actually doing here. But we can actually set it to modify another attribute, and we can say that this time I want it to modify the normals. Now you can see that you can use the smooth operator in this case to smooth out the direction of the normals without affecting the direction of the actual or the positions of the points. Very cool. Alright, so we have now 3 attributes here. Now the normal, the keep, and the scale, which we can use to actually drive the location of the trees. Okay, and if we look at them here, all of them have the proper values as expected. And moving, and they are fully persistent. Me changing these values will actually modify the normals or the values on the fly. Okay, so now what we want to do, go ahead and hide the normals here, is now to go into the scatter operation to actually scatter points like we did before. Okay, I'm going to go ahead and also set the relax iterations to none so that we get a nice little scattering. Okay, we'll also play with the seed a little bit just to get like a different distribution this time. Okay, now the thing to remember is that now we're actually passing all the point attributes through. In the attribute section, we can also choose what attributes we want to pass. We can do the points. Okay, so we can pass point attributes, vertex attributes, primitive attributes, and a detail attribute. Okay. The thing that is neat about this is that what it will do is that the attributes on the mesh interpolate in between the points. So, but the way how this will works is that it's going to pick the if the point falls in the middle of a face. Okay, it will actually pick up the value at this particular section of the actual primitive. So it's a very powerful way to actually get attributes in your mesh. And if we middle mouse here, we'll notice that we have our normals or points, the keep attribute and the scale attribute. Okay. Now, when we were doing this with the copy swap, if you remember, we use stamping variables to delete the trees that were coming in, which is not the best thing. It's actually a slow approach, because what you're doing is that you're still processing every point, and then for some points you're actually deleting the mesh that is coming in. Ideally, you should use the keep attribute to delete points before you feed it into the copy. That's much more optimal way of going about it. Okay. So the way how we do that is that we can actually, after the scatter, add a blast operator. Okay, the blast deletes, geometry, and you see me use the blast to do stuff, for example, like delete points 1 to 100, and be able to actually delete points that way. Okay. You can also, of course, use groups, which is cool. In this case, we don't have any groups, so that we can use. But one thing that we can do is that we can actually create a rule based on primitives. Okay. Now, what I'm going to do here is a small little expression, which is going to act like a wildcard, which is going to read an attribute, and based on my rule, is going to create a group automatically for me. Okay, so what I'm going to say here is that I'm going to say that the attribute keep, and the way how we actually reference an attribute here is by doing the @ sign. So we say @keep is bigger than 0.5. Now you will notice that nothing is happening. None of the points are getting deleted now, but that's because we do need to tell Houdini that this point, that the keep attribute is a point attribute. So I'm going to switch to the group type to points. Now you will notice that now the points are matching my mask a lot better. Okay. In reality, what we want to do is that we want to actually keep anything that is higher than 0.5 on the keep. So I want to say delete non-selected. So basically delete the opposites, which are basically the areas where we don't have don't have trees. Okay, where keep is less than 0.5. So now we can still come over to the paint operation for keep. You will see that by painting, we can add points to our little point cloud. Very cool. So now that we have all of this, we're going to go ahead and actually add a copy swap to start copying our trees into these new points. Okay. Now, what I think I'm going to do instead is to reuse this copy swap, since we're actually using stamping variables already. But I'll modify the stamping variables. Okay. So let's put this into here, and then if we look at the copy swap right now, doesn't look like too much is working at the moment. Okay, a few things are, but let's see what's going on here. Well, if you notice, actually, the actual thing that makes the trees lay down is actually working, because the trees are actually laying down. The keep attribute is already working because I'm actually deleting the points, so I'm not copying trees into many places. Okay. The only one that has changed here is the scale. So come back here. We don't need keep anymore, because keep is now being driven by the points that I delete. So let's go ahead and get rid of this one. Okay, we're gonna get rid of that variable, and we also need to get rid of this delete sub right here, because you remember this delete sub had a stamping variable which looks into the keep variable. We don't want that to happen anymore, so let's delete it, and now our trees are back. Cool, much more optimal than what we were doing before. We're going to keep the tree rotation, because that's useful to still rotate the trees on their y-axis randomly. but the tree scale needs to change in order for it to work. Okay, so the way how we're going to do that is that now instead of actually using this random function, if we want to really use the attribute that we have here, we need to actually multiply by the attribute that we have here. Okay, let me for 1 second pop the normals back so that we can see what's going on. Now we still have the original scale that we had before, which is the random scale. What I want to be able to do with this painting is to actually multiply the scale effect based on my brush strokes. Okay, so all that we have to do that is to actually multiply this by my painting operation, which in this case is the scale attribute. Okay, to do so, all that we have to do to access an attribute as a variable is to simply do $ and the name of the variable in all caps. Scale in this case. Oops. Let me just make sure. Actually, in this particular case, I don't think I have access to this variable because I lose my variables when I actually scatter the points. But that's okay though, because the attribute still exists on the points, so we can still reference it using a point expression, which I'm going to show you. So we can simply make this a little bit bigger. What we're going to do is to actually change this expression to do this instead. So we're going to do point, which basically is going to look into the points for me. And I'm going to say input path. I'm going to say, actually no, sorry, I'm going to say point, and then I'm going to reference the blast node that is coming before this. And then I'm going to reference the point number that is currently running, like we did with the random there. I'm going to look for an attribute called scale, and I'm going to look for element 0, which is, if it's a color, it will be 0, 1, and 2. Because it's just a linear value, 0 will work fine. There we go. So let me actually paste the expression here so that it can be a little bit more clear what I'm doing and show you what's happening. So I'm going to copy this whole thing here so we can see the full expression and kind of walk through it a little bit. So what we're doing here is that we're feeding a number that goes from 0 to 1 to 0.25, 125, which we saw before, okay? But the number that we're creating is basically this, okay? I'm going to copy that, and I'm going to paste it in a different line, okay? So the first part, we know what it is. It's just a random number that uses the point number as a seed to actually give it a random scale, okay? But then we're multiplying that by the actual scale attribute that we're painting, okay? And for that, we're using a point expression. The point expression is looking into the blast 1 node, which is the node right before the actual copy, and looking at the point number for this particular iteration, the same one we're using for the seed, looking at an attribute called scale, which if you look at the blast and look at the spreadsheet, you will notice that we have a scale attribute, and we're looking for the element 0, which in this case it is only one element, so it doesn't matter what we put there. In the case of a normal, this will be element 0, this will be element 1, and this will be element 2. Cool. So by doing that, we are then multiplying this value into this. Then what that means is whatever we actually paint on the scale paint is going to modify the size of the trees. So if we come here and actually paint white, the trees get bigger, but they still keep their random sizes from the random number that we are actually passing through, which is a good thing. We don't want to have to paint every tree scale. So here is a small size of little bushes, in which we can surround with some bigger bushes. Okay. So we're able to control all of this. Likewise, we can come here and change the expression to not use the random number. Okay, so basically we can take this out. And then we'll just use the point expression and just fit that in there. The only disadvantage with that is that then we lose some of that nice little randomness that we had, you know, that the random number was created. Sometimes it's really nice to actually get a little bit of random mix with the actual, you know, expressions that are driven by the user, just to give that extra touch of natural chaos into your expression. So we're gonna put this back here, and then here is our expression again, the way it is. Very cool. So let's actually go ahead and turn on the comb operation again. So we can see now that I can actually come here. And we can even do stuff like, we can even go ahead and start erasing my changes, for example, if I didn't like them in certain areas, and start lifting my trees back on. But if I wanted it to make it look like a tornado just went through, I can very simply just come here and just flatten the trees that way. There we go. We can even reduce how much you actually smooth the operation if we want a little bit of more noise. And all of that stuff will still work. Okay. Very cool. All right. So I think that probably covers it for today. So just to recap, and I'll delete the notes that we don't need anymore here. What we learned today is that we can create attributes, which we did here. We created a scale attribute and a keep attribute. We came here and actually painted their values in the canvas to actually make it, so actually give some values, you know, user inputted value into this. We create a normal attribute here, and we're able to actually convert using the coin sub, as well as smoothing it using the smooth sub, okay? To give direction to the trees. We scatter points there. The points automatically pick up the interpolated values on top of the surface and blasted any points who were not outside of our keep mask that we created. We use that to copy the trees. And then we also went ahead and merged back with the terrain and just put a null right here to actually visualize the end. And in fact, that should be a null. Let's go ahead and make this a proper output. And there it is. And just to reiterate one more time from the expression, the point expression, it first wants to know what node you're actually what are you looking at a point at, what the number of a point is, the attribute that you're looking in that particular point, and the channel for that. Okay. Well, thank you for watching, and we'll see you on the next lesson.